record the lesson again later on. So here we go. We're picking up with right triangle trigonometry. And as we consider right triangles, we like to say that this is an angle theta, and then this is my 90-degree angle. And given that type of right triangle, we can label all three sides one of three terms. So this one is the hypotenuse. It is the longest of the three sides. It's always across from the 90-degree angle. If you were to actually draw the angle theta like this, notice that one of the sides is the hypotenuse. The other side is the adjacent. Adjacent means next to. Adjacent means next to the angle. You can see that the side helps make up the angle. And then finally, the one that sits across from the angle is the opposite side. And so we have opposite, adjacent, and hypotenuse. You should have seen this in geometry. SohCahToa. Sine is the opposite side. Sine of the angle is the opposite divided by the hypotenuse. How can you remember that? Look at the first three letters. Sine is the opposite divided by the hypotenuse. Cosine is the adjacent divided by the hypotenuse. And finally, tangent is the opposite divided by the adjacent. There are three other trigonometric functions: cosecant, secant, and cotangent, which we will not make use of during this time. Good? All right. It says now, find the exact value of 6. We won't do 6. We're going to do 3. Trigonometric functions given theta for the 4 theta, given the legs of the triangle are 15 and 7, we roll 15 and 8. So I have legs of 15 and leg of 8. And I want to determine sine of theta, cosine of theta, and tangent of theta. You tell me, what side is 8? Is 8 the opposite, adjacent, or hypotenuse? It is the opposite. Thank you. You're very intelligent. 15. Adjacent. And then this side would be the hypotenuse. So if sine is the opposite over the hypotenuse, I do not have the hypotenuse at this time. Anybody got a clever way of coming up with the hypotenuse? Starts with a P. Pythagorean theorem. A squared plus b squared is c squared. So we'll take 8 squared and add that to 15 squared, and that will produce for us, we'll call it c, c squared. 8 squared is 64. 15 squared is 225. That's equal to c squared. 64 and 225 make 289. As I take the square root of both sides, I get 17 is equal to c. Now that I have all three sides, I could go ahead and write the trigonometric expressions. Sine of theta is going to be what over what? 8 over 17. Cosine will be what? 15 over 17, the adjacent divided by the hypotenuse. And then tangent is the opposite divided by the adjacent. Opposite divided by adjacent, 8 over 15. Let's skip those next two and move to the types of problems that we really want to be able to solve for. With the Pythagorean theorem, you have to have two sides to find a third side. However, when you know trigonometry and SohCahToa and sine, cosine, and tangent, you just need a side and an angle. If you have a side and an angle, you can determine one of the missing sides. In fact, you could solve the entire triangle at that point. So we're going to say that these are all right triangles. And in each situation, I would like to determine what x is. We have an angle 42. We need to determine x. I label the sides as opposite, adjacent, and hypotenuse. What side is 9? Opposite. And x is the hypotenuse. So I'm given the opposite. I'm searching for the hypotenuse. Which of the three trig functions will I choose to use? Sine, cosine, or tangent? Let's list it off and see what we get. SohCahToa. You can see that opposite and hypotenuse are connected with sine. So therefore, I choose sine. That's how you decide which one to use. So we write out sine of my angle, 42 degrees, is equal to. Again, the ratio is opposite over hypotenuse. Opposite is 9er divided by hypotenuse x. Anytime students make the mistake that they're actually multiplying by something every time. In this case, you're going to end up dividing. I think the easiest way for people to solve this is to put this over 1 and then cross multiply. So 9 times 1 is 9. And then x times the sine of 42 is x sine of 42. I want to divide in order to solve for x. I will divide both sides by the sine of 42. So x is 9 over the sine of 42. You're going to have a calculator in order to solve these. If you do not have a calculator, I think I have a couple extras floating up here if you want to try to grab one. Or you can try looking at your old phone. I press mode and I first make sure I'm working in degrees. Make sure that you're working in degrees. If you're working in radians, you will not get the right answer. So I'm going to take 9 and I'm going to divide it by the sine of 42. Sine 42. Notice I get 13.45 is equal to x. Does it make sense that 13.45 is larger than 9? Does it make sense that this side should be bigger than this side? Yeah, because it's the hypotenuse, right? Should be the biggest one of all. So always make sure you can somehow check your answers or assess how reasonable it is. Question. So if you turn on your calculator and then you press mode, you want to make sure that degrees is highlighted and not radians. Does that answer your question? Excellent question. We move on to the second example. 14 is the hypotenuse. What side is x? Is x the opposite or is it the adjacent? Opposite would be across from the angle. This is the adjacent. So if I have adjacent and hypotenuse, which of the three trig functions do I use? Sine, cosine, or tangent? Cosine, because you can see adjacent and hypotenuse for cosine. So I set it up. The cosine of 63 is equal to, and again it says AH, so adjacent over hypotenuse, x over 14. Well, this one's quite easy to solve. I'll put this over 1 and I will cross multiply. X times 1 is x, and then 14 times the cosine of 63 degrees. And by the way, that is in many ways how they'll leave the answer in the ACT. They won't necessarily put it as a decimal. So you should get used to solving for it this way. I take the 14 and multiply it by the cosine of 63. And I get 6.36. Any questions on that one? All right. This last one. Is x the opposite, adjacent, or hypotenuse? It is across from the 27-degree angle, so it is the opposite. This is the hypotenuse. This is the adjacent. So if I am working with the opposite and the adjacent, which trig function do I use? I use tangent. Opposite and adjacent, I use tangent. The tangent of 27 degrees is equal to the opposite. In this case, it is x divided by the adjacent, 9.4. Again, I'll write it over 1. We'll cross multiply. X times 1 is x. We have 9.4 times the tangent of 27. .79. Don, it's good to know you're anti-communist. You always want to know where people stand. Was that a tough stance for you to take? Okay, all right. I appreciate your honesty. Take out that will be on the video. Just having a good time here, people. All right, so take out your worksheets. We're going to do a couple problems together. Make sure that you know exactly what you're supposed to do on your worksheet. Good luck to everybody in their competitions tonight. Sounds like we have hockey going. Sounds like we have basketball going. Girls hockey against Mankato West. Boys, same thing. Maybe it's North. It's North Mankato, right? It's no school. All right. So, a couple different problems you're going to try doing. We look at this first problem, okay? You're going to be solving for missing side just like we did, okay? So we'll set this up together. You can see that this is the hypotenuse. And then this is the adjacent side. Hypotenuse and adjacent. Sine, cosine, or tangent? Cosine. So the cosine of 37 degrees is equal to the adjacent divided by the hypotenuse. I cross multiply and I get 11 is equal to x cosine of 37. If I'm going to solve for x, I must divide both sides by the cosine of 37. 11 over the cosine of 37 is equal to x. I take out my handy dandy calculator. And I get 13.77. Just like the examples we just did, correct? Then let's move down to a different type of problem. Look at number 7. Can somebody tell me what's different about number 7 compared to all the other problems we've done so far? Yeah, we don't have the angle. No problem for us. We still label the sides. This is the hypotenuse. This is the adjacent. So I need to choose sine, cosine, or tangent. Just like the last problem, you saw hypotenuse and adjacent, you use cosine. Cosine of what? Cosine of theta. So this time, instead of actually writing an angle measure, you write the variable theta. And that is equal to the adjacent, which is 12, divided by 13, which is the hypotenuse. Your calculator is a handy-dandy way of coming up with the angle. When you're looking for an angle, instead of pressing cosine, you press second cosine. This -1, it doesn't mean 1 divided by cosine. It means what we call cosine inverse. It finds the angle for you. So whenever you're finding an angle, don't just press cosine, press second cosine, or second sine, or second tangent. And then just type in that 12 over 13. And basically what it says is, hey, if it's equal to 12 over 13, then the angle that would produce that would be 22.62 degrees. Is that a hand raise? Nope. Okay. All right, flip it over. We'll try to finish off with these two. Yesterday we almost got done with this one, not quite. So we'll see where we get here. The third thing you're going to be asked to do is solve triangles completely. This is very important because we're going to build off this for future lessons. We're going to always say that angle C is the 90-degree angle. Okay? The big letters are angles. The small letters are sides. All right? So this is angle C. We'll call this angle B. We'll call this angle A. Angle B is 32 degrees. So therefore, I'm going to write over here, C is 90 degrees, B is 32 degrees. The small letters are the sides. This is extremely important. If you don't follow this, you're going to be lost. If I go across from angle A, that's side A. If I go across from angle B, that's side B. If I go across from angle C, that's side C. It says that side C is 8. So I am given 3 out of the 6 parts of the triangle. I need to find the other 3. What is the easiest part to find up here? Angle A, because you know that all the angles must add to 180 degrees. So if I clear my calculator and take 180 and I subtract 90 and I subtract 32, you can see that I come up with 58 degrees. All right, now we have to decide, would you like to find side A or side B? Allie, you choose. It's up to you. No wrong choice here. Side A or side B? She would like to find side A. That is the adjacent side. Side 8 is the hypotenuse. So we're given the hypotenuse, we're looking for the adjacent. If you're given the hypotenuse and looking for the adjacent, will you use sine, cosine, or tangent? Cosine. So we set it up. The cosine of my angle, 32 degrees, is equal to the adjacent side divided by the hypotenuse. We know how to solve that. We cross multiply. 8 cosine of 32. And I get 6.78. Hey, if I know two sides of a right triangle, how can I find the third side? Pythagorean theorem. And we know that this is 6.78, and that is 8. So we set up 6.78 squared plus b squared is equal to 8 squared. We would like to solve that. I'm going to go ahead and take 8 squared. I'm going to subtract off the 6.78 squared. And so that tells me, 8 squared minus 6.78 squared. And when I do that, I get 18.03. That means b squared is 18.03. I square root 18.03. I get 4.25. Here's a great way to check to see if your answer is reasonable. Angle C, biggest angle. Side C, biggest side. Angle B, smallest angle. Side B, smallest side. Angle A is in the middle. Side A is in the middle. We are almost out of time, but we will make it through as much as we can here. We're very close. I'm going to label my angles C. Angle A, angle B. No, A is 5, and we know that B is 12. We're looking for side C as well. I can write down side A as 5. I can write down side B as 12. And angle C is 90 degrees. What is going to be the easiest thing to find in this situation? Side C. I can use the Pythagorean theorem. For the sake of time, we're going to write down 13. Now I have all three sides. Bell's going to go or not, but just give me 30 more seconds and we'll finish. J-Rod, would you like to find angle B or A? It's up to you. He wants to find angle B. That means this is the opposite. That means this is the adjacent. And this is the hypotenuse. Jonathan, you want to find angle B. Would you like to use sine, cosine, or tangent? It's up to you. So he sets up tangent of angle B is equal to opposite divided by adjacent. Folks, if I'm looking for an angle, do you remember what I press? Second tangent of 12 divided by 5. We get 67.38. Subtract all those from 180, you get 22.62 degrees. I can leave you there. Thanks for your patience. Just want to finish off that last piece. There is no lesson on Thursday. You will be practicing, and getting ready for your test on Tuesday. We'll have some in-class practice together. We will see you soon. Good luck in your events.